Wasabi, my crazies, how are you? So, this next topic is just building off what we learned yesterday, which is just to take an equation that's already in that modified vertex form and just identify what's the focus, the vertex, the directrix, and sketch the result. So, yesterday we were given a focus and a directrix, or vertex, and we were able to build the equation of a parabola, and we put it in this modified vertex form, and then we also put it in standard form. Today, let's take an equation that's already in that form and work backwards.
Try here. Stop. When does this happen in the movie?
Now. You're looking at now, sir. Everything that happens now is happening now.
What happened to then?
We passed then.
When?
Just now. We're at now.
Go back to then.
When?
Now.
Now?
Now.
I can't.
Why?
We missed it.
When?
Just now.
When will then be now?
Soon.
Let's identify the focus, the directrix, vertex, and sketch the graph. Okay, let's give that a shot. Here's one. It's pretty straightforward, but what it does require us to know is to get this directrix, vertex, focus, we have to know this, that modified vertex form looks like x minus h squared equals 4 times p times y minus k. Now, the h and the k, those are the vertex. P is the distance from the vertex to the directrix, or the vertex to the focus. So in this case, it's really weird. We only have an x squared on the left. So what does that tell me about my h? That it must be 0. Now I've got this 16y, but no other value. Not like 16y minus 10 or something. So I don't have a k either. So how do I turn 4 times p times y minus 0 into 16y? Well, that would be if p was 4. Positive 4 also, because as you can see, this is positive 16. So I think that would work. I'm just working backwards, knowing what we did yesterday. So my h and k look like they're going to be 0, 0. So I've got this vertex that's at the origin, and I'll put it in right now. That's my vertex. Now my p, the p value is positive 4. That tells me that this opens up. Nice. Because recall this, that p is the distance from the vertex to directrix or vertex to focus. Right? So if I count up 4 this way, that's my focus. If I count 4 this way, there's my directrix. So what's the equation of the directrix? What's the equation of that line? It's going to be y equals negative 4. Pretty cool. Now, remember yesterday, if I want to be a little more precise about my graph, I go to the focus and I move to the right and to the left the distance that is from the focus to the directrix. So that would be twice the p-value, so that would be 8. So let me go 2, 4, 6, 8 to the right, 2, 4, 6, 8 to the left, and that would allow me to graph or sketch, so to speak, a little more precisely. There we go. It's a pretty big salad bowl, right? It's very wide. That's our job today. Take this equation and find vertex, directrix, focus, and sketch the graph. Let's look at the next question. Okay, this is a little more full, right? There's more stuff. Remember, this is the h, this is the k, this is equal to 4p. So let's start dissecting this. Vertex looks like 2, 1. P, 6. Because 4 times 6 would give you the 24 that's right here. Okay. P is positive because it was 24 positive, so my parabola is opening upwards. So let me start right away with the vertex at 2, 1. Let me count 6 below 1, 2, 3, 4, 5, 6, and that will be the equation of my directrix. This will be y equals -5. How far away will my focus be? The same distance. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's my focus. So I've got vertex, focus. Now, this is definitely a parabola opening upwards. We could sketch, let's see, 2, 4, 6, 12 away. Wow, okay, so 2, 4, 6, 8, 10, 12, somewhere over here. And if we go from the focus 12 units to the right, it's off the page. But at least that will give us some idea of this being a super, super wide parabola, crossing through those 2 points at a minimum. Okay, so recall that when we do these graphs and we're sketching them, I just thought it would be a good idea to go to the focus and move to the right and to the left the same distance that the focus is away from the directrix, because that's the definition of a parabola. These points should be the same, equidistant. Okay, very good. So that's that. Let's try the next one. This you will do on your own, and we will check your homework tomorrow. Cool. Let's do this last one. I like this because it's negative, right? You have vertex. That will be located at 2, -1. It's the opposite sign. P is going to be equal to -4 because we have a -16. Let's start working. Let's take this 2, -1 right here. That's called my vertex. Now, the parabola is going to open down. Therefore, the directrix is on top because, like we said, the parabola opens away from the directrix. So where do I put that directrix? I put it the distance of P away from the vertex. So 1, 2, 3, 4 right here. There's my directrix. The equation of that will be y equals 3. Let me get rid of these lines that I made. Let's find the focus. The focus will also be 4 away from the vertex, except in the opposite direction. And we'll do black, okay. 1, 2, 3, 4 right here. That's my focus. And from that focus, let's sketch a little bit more accurately, okay? What's the distance from the focus to the directrix? That's 8. It's twice the p-value. So let me go to the left 8. 2, 4, 6, 8. And let me go to the right 8. 2, 4, 6, 8. Okay, perfect. Now, with a different color, I'll show you this parabola. Pretty cool. There we go. So we found the directrix, y equals 3. We found the vertex, 2, -1. The focus, 2, -5. Sorry, I actually didn't write that out. There you go. And we graphed. Very nice. So this was a quick lesson. I hope you enjoyed it and hope you find that it's getting easier, as this is now the second day that we're dealing with this structure. And as a quick reminder, this is the structure we're talking about. It's this really cool new way that we're able to look at parabolas, not just in standard form, but now in this really cool modified vertex form. Okay, have a great night. Zamfini and I will see you tomorrow.